Alright, welcome back, and let's actually get started with object-oriented programming. And to do that, let's create a package, and I'm going to call this OOP for object-oriented programming. There we go. Okay, I'm going to create a new class, and I'm just going to call this demo. I'm going to go to my main. Okay, so to show you kind of the intuition behind the object-oriented programming and how it can help us, let's say, for example, we have a person here. So person, we have string name equals Joe. We have string email equal to joe@testemail.com. We have, say, his phone is whatever we want there. Okay, so a person, right? These are attributes or variables, or we might think of them as more in terms of English, adjectives, right? These are descriptors. Okay, and then what does that object, what does that person do? What does the what's the activity that this person does? Behavior. All right. So we say that Joe can. We'll say something like name is walking, right? We can say name is eating, and so forth. You get the idea. Okay, we run this, and this is fine. Okay, this is no problem. It took us 5 lines of code to do this, so it's not bad. But what if we wanted to do? So what if we wanted to do this for another person? So what would we do? We just copy this here, and then we would change all this to say now the second person, right? And so instead of Joe, let's say we have something like Sarah. Her email is sarah@testemail. Her phone number is some other random series of numbers. Okay, so we run this here, and there we go. Okay, no problem. Okay, but you see that this is maybe not the most efficient way of doing it. So one way we could enhance is, let's enhance by adding functions to minimize code. Okay, so we do something like static void, we'll say like walking, right? And then let's take the string name as an argument, and we'll print the name is walking. Okay, so instead of actually printing this, let's just say let's call the walking function and pass name too, and then same thing up here as well. Comment this out, and we'll call walking and pass our name. So there you go. We get the same result, and the repeatability here cuts down a little bit, especially if we add more and more names, right? If we add more and more people. But you see there's a little bit of, even this is not the most ideal. So what's missing here, even one other way this method lacks is what about binding data and properties together? Or I say attributes, not data. These are people. So what if we want to, how do we ensure that the right methods go with the right people, or the right properties? So to take this even one step further, what we can do is create a class, call it person. Okay. In fact, let me put this all the way up here at the top. Okay, so if we recognize that these two people we created right here, we just created some variables and they were doing some work. Since they have the same types of properties available, we can actually create a blueprint or a template from which we can create any number of people, and we don't have to go through this process of individualizing each variable. We can create a blueprint, and that blueprint is called a class. So inside this class, it's called a person, and every person will have a name, every person will have an email, every person will have a phone number. Okay? Every person will be able to walk, every person will be able to eat, every person will be able to sleep. Okay? And then to make these into methods, we just say void, right? Void. There we go. And then we can just say sysout name is walking. Sysout, we'll say email, and we'll say sysout we have name is sleeping. Okay, so let's now, instead of all this, I'm going to comment all of this stuff out, even this method here at the bottom. Let's see, I did one too many comments. There we go. Okay, now that we have this blueprint, we can go back to our main. Then we can just say we want a person. We'll call it person1 equals new person. Now that person1 is going to have all of the attributes that we described in the person class. So they're going to have a name. We'll say, again, this is Joe. Person1 is going to have an email. We'll have a joe@testemail.com. Person1 dot phone. Again, it's going to be that same whatever we want to have there. And we can say person1 dot walk. Whoops. Person1 dot walk. Person1 dot sleep. Person1 dot eat. Okay. Now this is equal. Okay, so we run this, and there we have the exact methods we were hoping for. So what did we find here? So first of all, this process, this is called instantiating an object, right? We create a variable and point it to the class which we defined here. And this new operator, or this new keyword that we use, is Java allocating space for this variable. Okay, so we instantiate an object, then we define some properties, and then here, this is what we call abstraction. So abstraction is we only want the elements that are necessary for us at this time. So maybe we don't care, at least at this point, that he's sleeping or eating. We just want to know that he's walking. Later on in the program, then we can call person1 dot sleep, right? And so abstraction is the ability for us to at any time be able to abstract or extract or get information from that object, only the parts that we want. And so that's what we're doing right here. So this process then allows us to abstract data very easily and see how data is bound to the object, right? So we have a person1 object, we have these variables and these methods that are tied uniquely to that object. So let's say here we can create another person2 equals new person. Then once again we can say person2 dot name is Sarah, and then we can again call person2 dot sleep, right? Only what we want. Let's see, where's the error there? Oh, I took out a comment, I think. There we go. There we go. So we have learned a little bit about object-oriented programming. We talked about we kind of expand the idea of reusability. So we've created a template for one. We see how we're binding attributes and methods to the object, to that specific instance of the object. So that's we'll learn more about that and how memory allocation plays into that. But now we can call because we can extract only what we want. We can abstract what we are binding to the object. So we're kind of combining a number of different object-oriented principles here. So there's much more to learn about that, but that's the basics of it. We just see we can have these variables and methods in here, and we'll enhance this throughout our training.